Okay, in this video we will talk about another very important function, which is the greatest integer function. In fact, we call it a flow function. Why? Because graphically it looks like that. So for any real number, what is a greatest integer function? Like, if you have a number, say 1.75, which is not an integer, right? So if I want to look at the greatest integer function, it would be actually 1. Now, greatest integer function essentially means that it is a synonym to the greatest integer that is less than or equal to the number you are looking at. Okay, so 1.75, which is the greatest integer which is less than or equal to 1.75, that is 1, right? For 0.7 it is 0, right? So x is any real number. So we take x as any real number. We denote greatest integer function the way I have in the box there. Okay, so greatest integer function, okay, denoted the way I have just denoted it. It is the greatest integer that is less than or equal to the number that you're looking at, any real number. Okay, greatest integer less than or equal to x, if x is the real number I'm looking at. So x, the greatest integer function, x is nothing else but the greatest integer which is less than or equal to that value x. Okay, x can be some decimal value, some fraction or anything, but not an integer probably. Okay, so that is what is a greatest integer function. Okay, so now this is essentially, if you try to draw it, let's figure it out. Let's graph it. Let's graph this function, greatest integer function. What will it look like? I mean, you have numbers, real numbers between these integers, right? So 0, 1, 2, 3. I can make my axis -1, -2, -3, and so on. I can also make my y-axis, which actually denotes the function fx, right? So 1, 2, 3. Let's just put all the integer values. So -1, -2, -3. Okay, now between 0 and 1, there will be a lot of numbers, right? Between 0 and 1 there will be a lot of numbers. Now the number which is the greatest integer function less than or equal to the greatest integer which is less than or equal to all these numbers between 0 and 1. Okay, so that is my fx, that's my y. So my y value for 0.5, which is between 0 and 1, will be what? For 0.5, my y value will be 0, because that's the greatest integer less than or equal to 0.5. So the point for all the values between 0 and 1 will actually be just 0, right? 0. And the point for 1.5, which is between 1 and 2. 1.5 is between 1 and 2. So the greatest integer function, 1.5, will be 1, right? So for all the values between 1 and 2, the y value will be still. It will be constant. It will be 1. So there will be flat step there. So this is a step function. Essentially, this is a step function. Steps looking like this. The steps will look like this. Okay, so that's how this function will look like. So it is a step function. The greatest integer function is a step function, as we can see it. So what will be the domain of this function? Domain can be all real numbers, of course, right? I can look at any real number and then look at the greatest integer function for them. Now, what will be the range? What will be the range? Now, it can be any x, right? The domain can be any x, but what will be the range? The range will be only integer values, right? The range will be only integer values, and that's what we're looking at. That's what is the function. Only integers. That's what this function gives me. The function gives me only integers in the range space. As a range what I always get, I get for 0.5, I get 0, for 1.5, I get 1, for 2.5, I get 2, and so on and so forth. So I only get integers like 1 minus 1, 2 minus 2 as the range. So it maps all real numbers to the integer values, and that's what is this function. Now again, just like modulus function, even this function, special function, so it will have certain properties attached to it. It's a special function. It will have certain properties attached to it. So if say we are looking at n, which is an integer, okay, if we are looking at n, which is an integer, and we are looking at x, which is any real number, can be any real number between n and n plus 1. Between n and n plus 1, okay. X is a real number between n and n plus 1. Between n and n plus 1. Let me just write it so that we don't forget it, that it is actually between n and n plus 1. So x lies between n and n plus 1. Okay, so number one property says that the greatest integer function of minus n, now n is an integer, the greatest integer function of minus n is essentially equal to the minus of the greatest integer function of n. Now mind you, n is an integer. N is an integer. So if I take greatest integer function of minus 1, if I take greatest integer function of minus 1, it will be nothing else but minus of greatest integer function of 1, which is 1 minus 1. So it is minus 1 simply. Now second is that if we take greatest integer function x plus k equals to greatest integer function x plus k, because k already is an integer, okay, so I don't need to see its integral value again. So k is an integer, and minus x, okay, greatest integer function of minus x will equal to minus of greatest integer function x minus 1. And next is that x, greatest integer function x plus the greatest integer function minus x, okay. So you can take any number for that matter. You can take 1. So x is say 1.1, then 1.1, greatest integer function will be 1 plus minus of 1.1, greatest integer function will be minus 1. So 1 minus 1 will be 0, okay. So it is 0 when x is an integer. It's minus 1 when x is not an integer, okay. And if you're subtracting, then what you get is that 2x plus 1 if x is an integer, and it is only 2x when x is when x is not an integer, it's 2x plus 1. When x is an integer, it is 2x, or 2 into the greatest integer function x. That's what I mean. We will be looking at these properties into details. Let me just write these properties for you in this video. Greatest integer function x greater than or equal to k would imply that x is greater than or equal to k, and k is an integer, where k is an integer, okay. So if 2 is the greatest integer function and it's greater than or equal to k, then of course if x was 2.3, 2.4, it would have been greater than k, right? And similarly for greatest integer function x being less than or equal to k, then x will be strictly less than k plus 1. The similar logic holds there. So if it is 2 is the greatest integer function and it is less than say 3, then of course x would have been 2.3 0.1, 2.9, or even 3, it would be less than 4. So another property is that if the greatest integer function is strictly greater than k, now the strictly part comes out here, then x is weakly greater than or equal to plus k plus 1, and greatest integer function is less than k implies that x is strictly less than k. Two more properties to go, and in fact this one property says that the greatest integer function of x plus y should actually be equal to greatest integer function x plus the greatest integer function y plus x minus greatest integer function x. Okay, these two values actually should be equal. That's what the property says. We'll see how actually it is happening in the next video. The last property, last but not least, what I would like to write down as property is that the greatest integer function x plus the greatest integer function x plus 1 by n and so on and so forth. N is, mind you, a natural number here. We are taking n as a natural number. Okay, so that is nothing else but the greatest integer function nx actually. So we'll look into detail of these properties in the next video.